this starting material, this precursor material is coming from where? It's coming from a very simple sugar. It's coming from a very simple sugar, which is ribose, a pentose sugar, ribose 5-phosphate. And if you can recall, that similar sugar is present in our ribose 5-phosphate, where it is present in our body, in our structure. Ribose 5-phosphate, DNA. Apart from DNA, this ribose 5-phosphate is produced where? Which pathway produces ribose 5-phosphate? HMP shunt, good enough. So that means the starting material, the precursor material is coming from either the HMP shunt, from where it is going towards the synthesis of nucleotides and synthesis of DNA as well. So let's remain on this PRPP, phosphoribosyl pyrophosphate, and it is using an enzyme, PRPP synthetase. Remember, whenever there is synthetase, that shows that it is going to add up a phosphate group at the expense of what? At the expense of the ATP, right? And ATP is being utilized here. So when we say that it's a pyrophosphate, so that means the two phosphates joining together, adjacent to each other, as you can see over here, two pyrophosphates are already there, and at position 5 there is addition of one more phosphate, right? So then this PRPP is converted into the 5-phosphoribosylamine, that is adding one more amine group within it. And why it is adding one amino group within it? Because it has to borrow some of the carbons, nitrogens, oxygen molecules from these different types of amino acids, from glycine, from aspartate, from glutamine. So these are the donors. These are the donors of the components of these purine rings. So that means your body has a tendency to synthesize these purine rings from the scratch. That means if the purines are not there, that means if the ribose 5-phosphate are not there, even then if this basic structure can borrow some carbon, some nitrogen from glutamine, aspartate, and glycine, they can build up a 2-ring purine structure by themselves. Okay, so after 10 or 11 reactions by borrowing glycine, aspartate, carbons, nitrogens, and carbons from other precursors, it turned out to be synthesized in one of the important intermediate, which is known as inosine monophosphate. And this is said to be a first nucleotide, or you can say the raw form of the first nucleotide to be synthesized. From this inosine monophosphate, once you synthesize the inosine, from here you can synthesize 2 other type of nucleotides as well that we used in your cells, in your body, for the energy generation and rest of the functions as well. What are these 2 other nucleotides? Mute yourself, please, whoever. Sidra, mute your mic. Okay. So this inosine monophosphate gives rise to either AMP and GMP. And from this AMP and GMP, you can synthesize adding one more phosphate, making ADP, adding one more phosphate, making ATP. Same is the case with the GMP. So this is how, right from the scratch, by using a simple sugar, simple pentose sugar, you can build up your nucleotides by following these reactions. So this is the summary of the pathway. But this pathway, which is started in the body from the scratch using the elements of different molecules, this pathway is starting from the scratch. That is why we call it de novo synthetic pathway. That means the body is synthesizing them de novo, from the scratch, from the beginning. Okay. I just want to discuss you some structural features of these nucleotides, and these are clinically important structural features of purine. I hope that you are aware of these structures. Look at this. If you see, this is the structure of adenine. Okay, 2 rings having a NH2 present on the top. And what else? If this adenine is attached with the pentose sugar, that is, now you have a nucleotide base, a nitrogenous base, and a phosphate sugar. What structure this is said to be? क्या कहते हैं हम इस स्ट्रक्चर को जिसके अंदर एक शुगर और एक नाइट्रोजनस बेस हो? Come on, hurry up. It's the nucleoside. And if I insert a 1-phosphate group within it, within the same, somewhere here, it will become a nucleotide. So that means the nucleoside of adenine will be the adenosine, while the adenosine is having the same NH2 group. Now, what is the significance of this adenine? Can anybody tell me the significance of this adenine, NH2 on the adenine? Any one of you? No one, okay. The significance of having this NH2 on the, why it's not moving, it's hanged. Okay, right. So this is the same, you can see adenosine over here is the same NH2. But what's happening here, there is an enzyme which is known as adenosine deaminase. One of you told me that this adenosine deaminase is an important enzyme because deficiency of this enzyme can lead to one of the disorders, one of the congenital disorders. So what this adenosine deaminase is doing, this adenosine deaminase is removing this NH2. We know that deamination of proteins or amino acid is a reaction in which amino acids are removed from the amino acid in the form of NH3. So the same job is being performed by this adenosine deaminase, that is, it is removing this NH2 in the form of NH3. Now, what it is making them? अगर इसने इसका NH2 remove कर दिया तो फिर ये क्या बना रहा है? तो क्या बनेगा फिर इससे? Replace it with nitrogen base. बेटे बनेगा क्या इससे? If adenosine has lost its amine group, now it's no more adenosine. Now it will become inosine. As you can see that the amino group is replaced from here and amino group is removed from here. So without NH2, adenosine is an inosine. And what I told you in the previous slide, that inosine is what? Inosine is what? Inosine is the first of the molecules in the lineage of the nucleotide synthesis. Okay, so this you need to remember. So this is the job of the adenosine deaminase. Now what's happening? If we can summarize this picture, this diagram shows you the two pathways of the synthesis of the nucleotides and their degradation as well. How these two pathways are going to be synthesized and degrade them. I told you in the beginning that this is your inosine, which is your IMP, that can give rise to AMP or the GMP. And from AMP and GMP, either you can get ATP or GTP, which are the high energy compounds and the structural components of the DNA. But these AMPs and GMPs themselves, which are the preformed nucleotides in the body, they themselves are capable of synthesizing some new nucleotides in the body. As you can see that what's happening here, if from the structure of AMP, one inorganic phosphate is removed, अगर इसमें से एक inorganic phosphate निकल जाएगा तो ये रह जाएगा adenosine. और adenosine में से अभी हमने पिछले स्लाइड में देखा है कि adenosine deaminase में एक अमाइनो इसका अमाइन ग्रुप निकाल दिया in the form of NH3. Now it is left with the inosine. और inosine में से भी अगर purine nucleoside phosphorylase, recall the scenario जिसमें purine nucleoside phosphorylase की एक्टिविटी नॉट होती, तो अगर ये purine nucleoside phosphorylase इसका ribose 5-phosphate निकाल देगा inosine में से, तो now this inosine will become hypoxanthine. Now same is the case with the GMP, the same enzyme are being used over here, the same phenomena, but this time it is not going to make hypoxanthine but guanine. Now this hypoxanthine and guanine are having two choices. Either this hypoxanthine or guanine can go further to resynthesize this AMP and GMP, right? By using different sets of enzyme over here. And then particularly the hypoxanthine guanine phosphoribosyl transferase. So 90% of this AMP and GMP are being handled this way by the cells. So that means whatever the nucleotides are being produced, they are getting recycled in the synthesis of further for formation of the nucleotide bases. So this pathway, which is going to synthesize AMP or GMP or the nucleotide by using the same nucleotide precursors, which is 90%, is known as the salvage pathway, because the nucleotides are not being synthesized from the scratch from the beginning, as was the case in the de novo synthesis, जिसमें कार्बन कहीं से ले रहे थे, नाइट्रोजन कहीं से ले रहे थे, फॉलिक एसिड से कुछ ले रहे थे और दो प्यूरिन्स बना रहे थे, वो फ्रॉम द स्क्रैच दो प्यूरिन्स बन रहे थे. इसमें ऐसा नहीं हो रहा है, इसमें प्यूरिन्स ऑलरेडी बने हुए हैं, न्यूक्लियोटाइड्स ऑलरेडी बने हुए हैं, सिर्फ एक या दो एंजाइम के रिएक्शन से इसको सैल्वेज कर रहे हैं. यू कैन से दैट रिसाइकिल कर रहे हैं. So in 90% of the cases, cell do this job. But what happens in 10% cases, that this hypoxanthine is going to be oxidized. When it is getting oxidized, making xanthine, and xanthine further oxidized with the help of xanthine oxidase, then it is converted into the uric acid. So this uric acid is actually the end product of the nucleotide or the purine metabolism. So remember, uric acid is not the end product of protein metabolism. The end product of protein metabolism is what? End product of the protein metabolism, can anybody name? What is the end product of protein metabolism? Urea, yes. So end product of the protein metabolism is urea. But if you talk about the uric acid, it's not the end product of protein metabolism, it's the end product of the purine metabolism. And 90% of the purines are recycled, only 10% are going to offer you this uric acid production. That is why uric acid levels are kept in a very narrow range within the blood. Since if its levels are increased or elevated in the plasma, it will lead to a condition which is known as hyperuricemia, and persistence of hyperuricemia can lead to gout or gouty arthritis. So this was about the salvage and de novo synthetic pathway of the uric acid. Now let's talk about the gout, as most of you are knowing it, that these are the elevated concentration of uric acid in the tissues and blood. What they do, they travel to the joints and the synovial spaces where they become crystallized, and they make monosodium urate crystals over there. And the monosodium urate crystals, they become birefringent on the to the light. These are the cause of inflammation produced within the body. One more thing that I want to emphasize in relation to the kidney or renal functions, that the same crystals which are being accumulated in the tissue, in the plasma, the same crystals has tendency to get accumulated within the renal tubules, within the kidneys. And when the kidneys are affected, what they do, since they are crystals, so when these salts or these monosodium urate crystals are going to deposit it within the kidneys, they have tendency to make stones, the renal stones in the kidneys. So that is why this hyperuricemia or uric acid is affecting your kidney. Okay, this is hypoxanthine, which is oxidized to xanthine. Xanthine will get oxidized, making uric acid. When this uric acid is, ideally this uric acid should be excreted out of the body, either in the urine or, but what happens if it fails to get excreted, such as the case with diabetes or the hypertension? So it is start accumulating within the system, within the tissues, and when their levels are exceeding 8 milligrams per deciliter in the plasma, it leads to urate crystallization, which is known as gout. So 8 milligrams is hyperuricemia, but its deposition more than at 8 milligrams, and when it affecting joints as an inflammation, it is going to produce gout. You can raise your hands, whoever are present, for the attendance purposes. Okay. So this is the common presentation of the gouty arthritis. As you can see that the big toe, as we already discussed in the scenario, that there are more chances, the hallmark, the characteristics of this gouty arthritis is the deposition of these sodium urate crystals within the gout, so that they can become inflamed, swollen, and tender. Okay. This may be their radiological appearances. This is how this monosodium urate crystals looks like on the negative, looks like negatively birefringent on a plain polarized light in the synovial fluid. So synovial fluid was being examined like that just to identify the presence, because there are other types of crystals as well which can deposit it. So to differentiate it from the gout, this test is necessary. Okay. So there can be a number of reasons of the this gouty arthritis, but what I want to show you are the points just to remember. So we talked about the Lesch-Nyhan syndrome. It's a X-linked recessive disorder. उसमें क्या होगा? HGPRTS की deficiency होगी. तो जब HGPRTS की deficiency होगी तो क्या होगा? What will happen as a result of HGPRTS deficiency? Salvage नहीं हो रहे होंगे nucleosides, right? Salvage pathway will be blocked. So उसकी, it is characterized by mental deficiency, aggression, self-destructive behavior characterized by lip and finger biting. As you can see, that his lips and fingers are badly affected because of his biting nature or self-mutilating. And he will also having high urate levels in the blood. Why he will be having high levels of the urates in the blood? Uric acid क्यों बढ़ा हुआ होगा इसमें? इसमें uric acid क्यों बढ़ा हुआ होगा? Yes, because of the increased purine degradation, increased turnout of the purines. So there will be hyperuricemia. Acha, from here, what comes in your mind by these two diagrams? What you can see in these diagrams? Yes, PRQ, yes, you're right. By looking at these two, spatial environment. Why do they need to have a spatial environment? Yogita, for avoiding to get it. Yes, immunodeficiency. Yes. So because what we have discussed in the scenario that these children are having deficient lineages of the white blood cells, deficient gamma globulins or deficient immunoglobulins. So that means what happens as a result of infections, these are our white blood cells or the immunoglobulins which are the first line defense. So they come to combat or resist against the infections. So since these children are having deficiency of these white blood cells and immunoglobulins, so they are more prone to get infections. So they are kept in an isolated environment so that they cannot catch the contagious type of infections, the bacterial or viral infections from surroundings. So that is how it is, they are being treated. So what happens in this severe combined immunodeficiency? इसमें होता क्या है basically? Adenosine deaminase deficiency होती है, and adenosine deaminase क्या कर रहा था? What was the job of adenosine deaminase? What was the job of like this forever? नहीं बेटा ये इतना survive भी नहीं करते unfortunately. In times of infection, they need to be kept like that in controlled environment, but unfortunately they can no longer survive. ज़्यादा इनका नहीं है. अच्छा ठीक है, एडिनोसिन की डीएमिनेशन कर रहा था, एडिनोसिन डीएमाइनेस. तो इससे क्या इफेक्ट पड़ता है? इससे ये होता है कि जो डीऑक्सी एटीपी होते हैं ना, ये accumulate हो जाते हैं within the lymphocytes, the T cells and the B cells. So which are the active form of the inactive form of these nucleotides. So these ribonucleotides get inhibited. So ribonucleotide inhibition of ribonucleotide reductase inhibits the active form of these nucleotides within the RBC so that they can provide energy to the RBCs and be able to synthesize and regenerate these B cells and T cells. And one thing that you need to know that our immunity, the types of immunity are being conferred or offered by which type of cells in the body. कौन सी cells होती हैं जो कि immunity करती हैं offer? ये B lymphocytes और T lymphocytes ही करते हैं ना. तो जब ये B lymphocytes और T lymphocytes themselves are not performing their functions normally, lacking deoxy type of ATPs within them, so there will be no further production of either the lymphocytes or the immunoglobulins in the blood. So this leads to recurrent infections and tendency to have more infections. So this condition is known as severe combined immunodeficiency disorder. Okay. Now, what are the points of remember in synthesis of purine nucleotides? It has de novo synthesis. De novo synthesis में क्या याद रखना है? उसकी साइट याद रखनी है कि कहाँ होती है. De novo synthesis किन साइट्स में होती है? उसकी कैरेक्टरिस्टिक्स क्या हैं और एलिमेंट सोर्सेस, मतलब कहाँ से कौन सा अमीनो एसिड कार्बन दे रहा है, कौन सा अमीनो एसिड नाइट्रोजन दे रहा है, किस पोजीशन पे आके वो अटैच हो रहा है, ये आपको याद करना है. ठीक है, तो these are the points to remember. Then you have salvage pathway. Remember that HGPRTase deficiency or the Lesch-Nyhan syndrome is a disorder of synthetic pathway. It's not a disorder of degradative or the breakdown pathway of the purines. So salvage pathway का defect है Lesch-Nyhan syndrome. You need to remember that. Then anti-metabolites of purine nucleotides क्या हैं? Purines, amino acids और folic acid analogs ये क्या करते हैं कि जो उसकी regulation को affect करते हैं. Analogs similar type of structures, right? So they affect with the regulation, they interfere with the regulation of the purine. Then what you need to remember in degradation pathway, in degradation of purine, आपको याद रखना है adenosine deaminase deficiency, which leads to severe combined immunodeficiency, or formation of deoxyribonucleotide. That deoxyribonucleotide, it should be oxyribonucleotide to synthesize ATPs and ADPs in the RBCs, but there is a production of deoxy because of the activity of reductase, which leads to adenosine deaminase deficiency and severe combined immunodeficiency disorder. Then you need to remember uric acid or gout, which is of course the disorder of the xanthine oxidase deficiency, right? And these are the diseases associated with the defects in purine metabolism: hyperuricemia, gout, kidney stones, Lesch-Nyhan syndrome, severe combined